Please be seated. I open this public meeting of the PhD Committee of the Faculty of Human Movement Sciences by expressing our faith in God. Our help is in the name of the Lord, who has made heaven and earth. Before asking the opponents to speak, I invite the candidate to give a brief presentation of the research on which the thesis is based.
Dr. Magnificus, ladies and gentlemen. This presentation will not start if I wouldn't have pressed a particular key on my keyboard. Pressing a key is just one type of the many goal-directed movements that we perform every day. To perform such an action, we need to use our vision, and we need to plan and control appropriate movements that will bring our finger to the goal. In this case, it is relatively easy, because the goal of my finger movement is very well defined, and it is the button. There are, however, other goal-directed movements in which things become a little bit more complicated. Imagine, for example, that I want to grasp my glass of juice. Grasping is the simplest goal-directed movement in which fingers have no clear goal. Like when pressing the key, we need to use our vision to determine where the object is, and we need to plan and control appropriate movements that will bring our fingers on the object. The fingers, however, can end in many combinations on the object. And here we can see just two examples. Having a plethora of options is certainly a great advantage, and it indicates a very flexible motor system. It also poses, however, some problems. For instance, out of such a plethora, we need to make a selection. How does the grasp emerge? What is the critical information that we use to plan and control such an action? Do we just move our hand close to the object and shape our fingers to match the shape of the object? Or do we make some more elaborate decisions? To examine this and other relevant questions, we perform experiments. In these experiments, we ask healthy volunteers to reach and grasp objects. Meanwhile, we track the kinematics of these movements. This is usually done by means of specific cameras to track the positions of special markers. These markers are attached to important body landmarks, like, for example, the nails of the thumb and index finger of the moving hand. Therefore, the cameras can track the positions of the markers, and then we can determine how the fingers are moving. We can also determine other features of the grasping movement, like, for example, where on the object the fingers end. The position on an object where the fingers end in order to grasp it will from now on be referred to as grasping points. The selection of the grasping point is not trivial. We need to satisfy some criteria when selecting grasping points, like, for example, the stability of the grasp. To ensure a stable grasp, we need to consider some characteristics of the object, like, for example, its center of mass, size, or shape. Obviously, when I want to grasp a knife like this, I can only use more or less two types of grasps. Therefore, my motor system has not a real problem, because the selection is just made out of two options. Other objects, however, like glass, can be grasped in many more ways. And it is not strange to grasp a glass, or a cylindrical object anyway, in a very awkward configuration, as long as our intentions are met. Yet, people grasp standalone spherical objects in a very consistent way. Imagine, for example, this situation where we see my hand with the markers attached to the fingers and a short glass of juice. Here we can see a simplified top view of the same image. Now, if I start moving my fingers towards the object, the cameras can track the position of the markers, and we can draw the trajectories of my fingers with the black lines. And if I perform this action more times, then we can draw more lines. What we will realize is that these lines, these movement trajectories, are very similar to each other. If I want to grasp a taller object, let's say with a milk, the movement trajectories will again be very similar to each other, but also very similar to those towards the Jews. In some cases, however, this will differ. When, for example, the relation between the position of the object and the position of my hand is different. When grasping the short object, in this case, my index finger will move over it. But when grasping the tall object with the milk, the same finger, the index finger, will curve around it. Despite the different trajectories, the selection of the grasping points, the goal of my fingers, is very similar. People make consistent selection of the grasping points, and in this thesis, we have observed this even when local or global constraints are imposed to the arm or body posture respectively. Even when people are confronted with poor visual information, they make the same consistent selection of the grasping points. These studies, however, are concerned with a relatively stationary environment. People, however, interact with a world that dynamically changes. Imagine, for example, the waitress bringing my favorite glass on her tray, and because I'm impatient, I want to reach and grasp this glass before she serves me. At the moment I start my movement, she decides to rotate the tray and bring it in front of her, so that she will be able to serve me. Obviously, I will miss the glass, but luckily, I'm able to correct my movement. Such correction takes place with a delay of at least 100 milliseconds, because that is the minimum time that I need to process the new information I get from the changing environment. The fact that I can follow the position of the object has been suggested to be an automatic reaction, governed by an automatic mechanism. Does the same hold true when we select grasping points? We examine this in the laboratory. We ask participants to reach and grasp either a cube or a ball. The object in question, in some trials, rotated briefly as soon as participants started moving towards it. Obviously, when grasping the cube, participants followed the rotation of the cube and changed their grip in a way that the fingers would end at the usual grasping point side. But when grasping the ball, there was no reason to do so. However, our participants initially responded and rotated their grip, rotating it in the direction of the rotation of the ball. However, they neglected this response soon and grasped the object with their usual configuration. Why did our participants neglect this response? Was it governed by an automatic mechanism? Or were they able to reconsider their selection of the grasping points? To examine this, we asked participants to grasp just a cube, which was oriented ambiguously. Therefore, it was not clear which pair of sides was best to be grasped from. In all trials, participants followed the rotation of the cube, like in the previous experiment. But in some trials, this initial following of the originally planned grasping point was followed by another response, a switch response, which led the fingers to the other pair of sides, suggesting a re-evaluation of the circumstances. This was performed much faster than the time it takes to initiate the movement. The message is clear. In order to cope with a dynamically changing environment, we need to process information, and we need to process this information as fast as possible. Some information have an essential role. We saw that the grasping points have a fundamental role, and they are being reconsidered during the grasping movement if necessary. In this thesis, we saw that the grasping points are fundamental in how the grasping movement is organized and executed. People can grasp an object in many ways, yet they show strong consistencies on the way they grasp an object, although they can change this way if necessary. The end of the grasping movement determines largely how this movement is organized and executed. Thank you for your attention.
I invite the members of the PhD committee to join me at this table. should now like to ask the candidate whether he is ready to defend his thesis.
Rector, on your authority and as authorized by the College of Deans, and in accordance with the doctoral examination committee in the Faculty of Human Movement Sciences, I am prepared to defend my thesis entitled The End, in order to obtain the degree of doctor.
The first opponent who will discuss your thesis with you will be Dr. Hachitaki, Associate Professor in Motor Control and Learning at the Aristoteles University of Thessaloniki. Dr. Hachitaki, I'd like to welcome you here in this ceremony, and I'd like to thank you for your efforts to be with us.
Thank you very much. On the authority of the rector and by virtue of my right, Mr. Voudouris, I have to ask you some questions on the results of your thesis. And I will start with the first one. Your first study showed that regardless of the height or the shape of the object to be grasped, our fingers end on the same positions, always. This assumes that even objects of different mass or inertia characteristics could end up at having the final positions at the same points. I'm asking if this is a reasonable assumption based on the results of the first experiment.
Learned opponent, thank you for your question. I think this will be indeed the case, as long as the characteristics of the object, like the center of mass or the symmetry of it, will be the same. Obviously, if an object has an asymmetrical mass distribution, I would expect that the fingers might end in a different way, so as the manipulation of the object would be as stable as possible. But if it's not obvious what the characteristics of the object is, the characteristics regarding the center of mass, for example, then I would expect that in the first time that one is grasping for such an object, would indeed lead to the same grasping points as those that we illustrate in chapter 2.
So then I will ask you, bringing in an example from real life. A friend of mine was describing the other day an incidence of being served a glass of water. She misunderstood the glass. It was plastic. She thought it was glass, and this resulted in an overlifting movement. I guess that in that case, the fingers you're going to use or the landing positions of these fingers on the object would be different. Would you agree?
I would agree, because we need to make some planning before the movement starts, and this planning takes into account a lot of factors, like, for example, the material of the object, or how heavy is it, for example. What I realized from your friend is that he or she overestimated the weight of the object. Therefore, planning of the grasping movement was a little bit different than the one that was optimal, let's say, in this case.
Okay, thank you very much. I will then move to my next question. Your grip orientation variable is a very nice variable, but it gives us a compound measure of what the two fingers do together. Yet, your results suggest the independent movement of the digits to the object. Is there then something like a two-finger synergy planned by the central nervous system, or you still believe it's independent movements of the fingers?
Well, in this thesis, we mainly focused on how the goals of the fingers movement are selected, and we cannot really well determine how these movements emerge. Of course, there are different kinds of approaches on how the grasp emerges, whether it's indeed like a synergy, like coordination between the fingers, or whether the movements are independent. my opinion, there should be a coordination, because obviously one finger cannot end on the object, whereas the other is 20 or 30 centimeters away. There are anatomical constraints that we need all to take into account. And of course, there should also be coordination, because it is not logical one finger to arrive much earlier than the other on the object, because then this will not lead to a stable grasp. Grasping orientation, however, I think nicely illustrates how the grasping points are selected, because if only one of the fingers ends on another grasping point, the grasping orientation would change. And the only way that the grasping orientation can change, may be relatively stable, but the grasping points of the fingers are different, is if there are adjustments on the vertical axis. And I think that these adjustments on the vertical axis can take place when there is freedom to do so. Like, for example, when grasping is here, and we saw in one of the experiments that when people grasp a sphere, even in the presence of an obstacle, the grasping orientation, the vertical grasping orientation doesn't change. So this is not the reason of having the same horizontal grip orientation. So I think that the grasping orientation, in the way that we determine it, especially on the horizontal plane where it's much more freedom, is an indicative measure of what grasping points people select on the object, where they select to end their fingers on it.
I would agree with you that probably our central nervous system plans a two-digit synergy. However, the results of your study with the obstacle, I think it's study 2, clearly illustrate that there is an adjustment in the grip orientation where the obstacle is placed close to the thumb, whereas there is no such an adjustment where the obstacle is placed close to the index finger.
Yes.
Yes.
But if we see on figure 3.5 in page 51 of the thesis, we see that the standard deviation of the grip orientation of the index finger is much larger than that on the thumb. And this is mainly because when the constraints were imposed on the index finger, subjects were able to rotate their grip into different directions, whereas when the constraints were imposed to the thumb, to my opinion at least, it was very difficult to make adjustments of the grip orientation in both directions, because otherwise the palm of the hand would not be visible, and then it was not advantageous. The fact that we don't have a significant effect, I think, suggests that there is no systematic changes, but there are no changes. Figure 3.4, I think, shows that people are able to modify their selection, even when the index finger is constrained. Just this is not systematic.
Which brings me to my last question, I think. Pre-planning, that's a big word to say. Pre-planning. And your results, the results of the first study, show that the final finger positions are pre-planned. However, this is not so clear in the rest of the studies. So what would you suggest are finger positions pre-planned based on the results of this work?
I think that there is some evidence that shows that people are able to pre-plan their grasping points, like the one that you just said in chapter number 2, the first study. I also think that in the last study, the one with the rotating object, there is some evidence that may be interpreted like this, because people can modify their grip orientation according to the rotation of the object, even when there is no reason to do so when grasping the ball. And I think that also in figure 6.2 we show that the grasping points on the object when grasping
The next opponent will be Dr. Bongers. Dr. Bongers is Associate Professor at the Center for Human Movement Sciences of the State University in Groningen. Dr. Bongers, please.
By the authority of the Rector Magnificus and in my own right, I would like to congratulate you with your thesis. I would like to extend these congratulations to your supervising team. The thesis looks nice and it reads well, and I particularly would like to tell you that I'm impressed by how you managed to present difficult results in very clear figures, and they really help me a lot, and they look smart. Good done, well done. But that were the compliments. Now the more critical questions. So let's start simple. Do you agree that you try to argue in this thesis that the endpoints of the digits on the object are planned? Simply yes or no would do.
Learned opponent. First of all, thank you for your kind words. Yes, in this thesis
Thank you. Okay, that's great, and we agree on that, and I would like to challenge this interpretation in a series of questions. Chapter 2, you compared the grasping points when objects were grasped from different starting positions and at different locations. There is no effect of object type on the grasp orientation. And is it that these results lead you to, I mean, among others, lead you to conclude that the grasping points are planned, independent of this object type? But might it be that the object type, how you vary this, is not the right variable to manipulate, so that your conclusion could have been different if you used different object manipulations of object typing? You use a cylinder and a sphere.
Yes. Of course, if we would have used different object types, which would not offer a lot of freedom to have a broad possibility of grasping points, then perhaps we would find a strong effect, because the orientation and the shape of the object largely determines how this object is grasped. That's why we have used object types that offer a lot of variety of grasping points, like the cylinder and the sphere, and we decided to use a short one and a tall one, so that we manipulate in a way the movement trajectory towards the object without imposing other constraints than this.
Okay. Now, how do you derive from these results that it's the location that is planned? So in chapter 3, you placed obstacles in the scene. In experiment 1 close to the object, and experiment 2 close to the position of the elbow. But still you use round object and allowing for freedom. So I thought, why doesn't he use cubes? So I was very pleased that at least in chapter 6 you started to use cubes. Why do you think that fast, and in the end of chapter 6 on page 114, you make this conclusion, you talk about the fast response times there.
Yes.
You have it, yes? The second paragraph. I just can't follow the reasoning there. Why these fast response times lead you to conclude that that it are the position of the digits that are controlled? Because you explicitly state that grasping arises from controlling the digits position rather than controlling grip formation. But I don't see how that would follow from the fast response times.
In this last study, we show especially the second study, that the responses to the rotations to the subcomponents. One of the first one, the latest 115 milliseconds about. The second one a little bit more, slower, with the re-evaluation of the grasping points around 160 we claim in this paragraph, that grasping may arise from controlling the digits towards points, is based on the finding of the really fast initial correction. Of course, later on the movement, people reevaluate this because the situation becomes different and it's more advantageous to grasp the object in a different way.
Yes.
But this takes longer.
Yeah, but you refer to the paper of Van de Kamp et al., who showed that the grasp, also the grasp component can be adjusted very fast, also in the lines of 100, 125 milliseconds. And they argue that it's the grasp component that is adjusted. So the fact that you have fast response time does not mean that you cannot show it in the grasp component.
Yes, and I cannot recall all the aspects of this paper, but I think there are some dependencies.
Ask me.
I think there are some dependencies on the movements of the fingers, and additionally, I think the author's claim try to support the view that grasping is not just moving the single digits.
Yes.
But this has something. I don't see what this has to do with the selection of these endcodes, because it's something different moving the digits, and it's something another aspect of the grasping movement.
Well, if you think that the digits that are controlled, then you need endpoints of the digits. When you have two components, a reaching component and a grasp component, and you don't need to specify the end goal of these individual digits.
Yes.
So that's how the fact that you have the idea that you think that the grasp points are planned is related to the idea that you have your digits are controlled individually.
Well, I think that what remains to be done is to test the other view of independent movements in conditions where sudden changes occur, like those that we show in chapter 6, because so far this framework perhaps has been makes predictions, let's say, situations where no perturbations occur, and perhaps then we could also give some more ideas whether indeed this is the case or not.
Well, I would like to. I'm glad you answered this. If you bring this up like this, because you talk a lot about emergence throughout the thesis, but the emergence is always related to the trajectory of the digits, but never actually related to the positions. And you could think whether it might be that the end locations are emergent from all kind of control laws. And in that respect, you present actually three models, but one model of Smeets and Brenner, one of Rosenbaum, where colleague Moelenbroek has contributed. But you do not present the model of Ulloa and Bullock in your thesis, who actually model the reach, the grasp, and orientation component. And in that model, you can set a target, which is the object, and from there on, the grasp points emerge. So you don't need to pre-plan your landing locations in the model. So you were just not aware of the model, which is fine. Or did you have another reason not to discuss it?
The model that I heard from your mouth, to be honest, I haven't heard it.
Okay,
before,
that's fine. That's
I
fine.
didn't hear it well.
But then, what would be then a good experiment in your view to test the idea of Smeets and Brenner compared to a model that starts from the synergy or the grasping component, and to compare these two views?
Well, of course we can compare views, but I think we need to have a baseline of what we are comparing, because if one view suggests that with grasping emerges by positions, selected positions, whereas others are concerned with how these positions are reached, are achieved, and I think that it will be a little bit hard to compare two ideas that do not have a common characteristic, except that it's a grasping movement, because one aspect is how the grasping points are reached, or how the fingers move to these points, whereas the other what you suggest is a model that defines the grasping points in advance. And I think a Smith and Brenner model defined the grasping points in advance, so that that's logical, but we need to know how these points are selected and on what basis are these points selected.
Okay, thank you.
The discussion will be continued by Professor Meulenbroek from the Donders Institute for Brain Cognition and Behavior at the Radboud University in Nijmegen. Professor Meulenbroek.
Thank you, Chairman. By the authority of the Rector Magnificus and in my own right, I would first of all compliment you on your thesis. I think it's a convincing series of a clever empirical series of studies, professionally reported with an elegant layout. I'm particularly pleased with this work since it satisfies my narcissistic nature. In referring, you refer frequently to the experimental and computational modeling work that I conducted on reaching and grasping in the 1990s together with colleagues. It's always flattering to see a young scientist refer respectfully to the contributions to science of an older colleague who is turning grey much at a much too young age. But now, the serious part. I have a number of questions on the way you describe, refer to our posture-based motion planning model, and also I'd like to ask you to extend your knowledge to other domains. Let me start with my first question. You introduce the posture-based motion planning model of reaching and grasping on page 11 of your thesis, and you refer to our theory as a complex model that describes how whole arm grasping movements are performed in the presence of obstacles. Then you mention that our main suggestion was that possible hand and arm configurations for grasping an object are evaluated on the basis of a constraint hierarchy, which determines the most suitable configuration that satisfies obstacle avoidance and postural comfort. One element, crucial element, is missing in that statement, which I'd like to challenge you on. I appreciate that you call our model complex because you have also shown that reaching and grasping and its control is quite a complex process, even though we don't think usually of it as such. But in our theory, we have three elements that we immediately stress, and that is the third constraint, that is spatial accuracy. And our model is limited to the kinematics, but spatial accuracy is a crucial element driving perhaps the selection of goal positions, reaching and grasping points. Spatially accurate, and also with anticipation and pre-planning cognitive processes in mind that we emphasize. Of course, trying to prevent an object from slipping from the hand is something like an extended spatial accuracy constraint imposed on the grasping movement. So, was this a slip of writing that you missed our third constraint of how do you think about our spatial accuracy constraint in the context of your studies?
Learned opponent, thank you for your nice words and compliments. Indeed, what you say is true. I don't miss this point, but I believe that spatial accuracy is, I agree with you that it's a component of this framework. One of the many components of this framework, and that's why I call it complex, because also the modeling of prehension movement or rotor movements, there are many parameters that are being considered. So it's a little bit hard then to determine, in my opinion at least, what parameters are essential for this movement to occur. On the other hand, I like the work because grasping is, as you said, also a very complex movement that, and as we also saw in other chapters, in chapter 3, for example, that people need to overcome constraints of the movement, and that we cannot really forget about the postural configurations. And this is an aspect of the model that you have worked on, which is important to understand how people cope with avoiding obstacles and avoiding other constraints that are imposed. Yet this does not claims of a simplicity of this model. So then I will come back to my first point, that it's indeed hard to say why people grasp the way they do. I mean, through these simulations, what the important parameters that are being considered.
Okay, thank you. Then my next question is about chapter 2, where I'm a bit puzzled again with the way you refer to our model and relative to your findings. You claim that our theory explicitly states that for discrete point-to-point aiming movements, also in grasping movements, that the goal posture is planned before the movement to the goal posture is planned. That is at least our claim. Whereas the conclusion from chapter 2 seems to be, in your view, seems to be different. And that statement that I just said is, in my view, completely in agreement with your results, whereas you conclude the opposite. So what is the reason for this inconsistency?
I think that the posture-based planning is claiming that people plan way in advance and can grasp objects in strange ways if this will satisfy the future manipulations. And this is an indication that the grasping posture may be planned before the movement. And I think in chapter 2 we show that the grasping points are selected before the movement towards these points has been determined. So I think that I don't see any inconsistency between these two at this point. Because in the model that you refer, the grasping posture is selected in advance, and we claim in chapter 2 that the grasping points are selected in advance.
Okay, and now I touch upon the inconsistency in our theory, and I challenge you to pick it out. Why are we inconsistent ourselves in our theory when we state that the end posture is planned on the basis of travel cost? So,
well, this is how the work has been defined. Well, this is how the travel costs. The travel costs in the posture model are being implemented in a way that that you consider the energy to consume. Well, not the variability.
Exactly.
But the work. And in movement like grasping, I think that the variability may play a more critical role than work, because in a precise grasping at least, variability is very essential in order to fulfill the task, whereas work may not be the most critical aspects.
Okay. A final question, if I may.
If there's a small one.
A small one.
Especially if the answer can be also small.
If you would have to plan to make a robot arm, how many digits would you give the robot hand?
I would give 5 to be
5.
aesthetically nice.
Okay, thank you. Short answer.
The next opponent is Dr. Kuipers, working at the Department of Human Technology Interaction at the Technical University in Eindhoven. Dr. Kuipers.
By the authority of the Rector Magnificus and in my own right, I would like to continue this discussion. First of all, I would like to congratulate with your fine thesis and your clever experiments, and you have gathered a lot of empirical data but I still think there's much more to be gained from those data. And I would like to talk to you about it. First of all, what struck me was the title of your thesis. So, the end. So when you think about it, it could mean a lot of things, right? So you did a lot of field work and bars, I got the impression. So maybe you're regretting that this is ending, maybe you're looking forward to the end of your PhD, or perhaps it's just wishful thinking. However, I'm curious whether there's also a more scientific meaning to this title. And maybe you can start with that.
Learned opponent, thank you for your kind words. Of course, after 4.5 years working on this project, I was really looking forward to this moment. But I think the end, the title on this book refers mainly to the end of the grasping movement, which is the grasping points, which are being examined thoroughly, well, at least in many, in 5 studies here. And since all studies are concerned with the selection of the grasping points, are concerned with the end of the grasping movement.
Okay, I was hoping you would say this. So maybe I can convince you that you should call your thesis the start. Because what you in the introduction and in the discussion you say that the ultimate goal of grasping is to select grip locations. That sounds a little bit strange.
It depends on how we approach this sentence. Of course, when we plan a grasping movement, I assume that we have other intentions, like for example, to drink from the glass that we're grasping, or to move the object that we're grasping. So the ultimate goal of the grasping movement is then the manipulation. But if we look at this sentence from the perspective of examining the grasping movement itself and not the manipulation, then I would say that the grasping point is very essential because if we don't select suitable positions, then the grasping movement will fail, and then there is no manipulation possible.
Sure, but I would say that the selection of grip locations follows from other considerations. And one idea is that, in your example, in the presentation we gave, you showed a knife and you said there are 2 ways to grasp this knife. I'm pretty sure I would never grasp a knife like that. And the reason is that I plan the grip points or the whole grip of the hand based on what I want to do with it. I may want to stab somebody, or I may want to put it in the dishwasher, and it really will differ. So the grip, I may want to slice some fruit if I'm a more friendly mood. The way I grasp the object will differ completely. And so I would say the goal is not the selection of the grip points, but is what your intention of what you want to do with that, and the selection of grip points is only following this more ultimate goal.
I totally agree with you. That's why I had the subsequent slide in the presentation, which the hand was grasping a glass of juice, and of course it's a little bit irrational to grasp a glass of juice like this when it's full, but I believe that if my intentions are to rotate the glass upside down, then of course I would like to grasp it. Not of course, but it would be very likely to grasp it in a completely different way. Still, I have to consider my intentions to plan and control what the grasping points would be based on these intentions.
Okay, so you wouldn't rename your thesis to the start?
I would stick to this.
Then I would like to continue the discussion on the end of your thesis, the general discussion. Because throughout the chapters I missed a little bit more theorizing about the implications of your work on existing, let's say, conceptual models. So, as you are aware, Jean Aroux has this dichotomy between transport and hand-shaping. Glover and Dixon have a dichotomy between planning and control. Mulder and Goodendale have a dichotomy between perception and action. Ungerleider and Mishkin between the what and where pathway. Smeets and Brenner have a thumb and an index finger. All those models have two things that need to be controlled, more or less independently, because that's what the whole thing is about. They are of course not independent, but it's like a rat race between models. Which model is easier to explain the data? So, given your thesis and all your experimental work, which model do you favor and why?
I think this model are concerned with how the movements of the figures are being controlled, how the movements are being executed. We haven't looked into this aspect, although we could have looked at this, because we were mainly interested on where the figures end on the object. I think our results could be interpreted in a way that they would support the two figures framework, but of course this is not ultimate, and I wouldn't like to claim that our work clearly shows that grasping is being controlled from two independent movements of the fingers. Moreover, in this thesis we impose a lot of constraints, and to my knowledge some of these models do not take into account how grasping is being controlled in the presence of obstacles or in the presence of visual information, how the grasping points, how the grasping posture or the grip component, let's say, is being selected when we have uncertainty about the shape of the object, and also how these components work when perturbations occur. So I wouldn't select one of the models as being supported by our results at this point.
Yeah, so maybe I should pick out one model. So in Glover and Dixon, there's a distinction between planning and control. So basically they say planning is I plan my grip locations, and then I have plan a path, and then when I carry out this path, I have some control system, and this can explain why some illusions give me different movement patterns, but not different grip locations. And of course, Smeets and Brenners have a different view on this. But do you think that that you have evidence against this model? Because you don't say anything about this. At least not that I remember.
About the model of Glover and Dixon?
Yes.
No, it was not part of this thesis, and it was not. It didn't play an important role on how the experiments were designed and whether people controlled their movements. This model has not been really accounted in this work.
Okay, so the way I interpret your you also don't say it very explicitly, but it seems to me that you think of grasping as first you select grip locations, and then you do some path planning using perhaps the minimum jerk model, and then you do the movement, and maybe there must be something else going on, because in chapter 6 you clearly show that both the grip selection points and the path, they are adjusted online.
Yes.
So how do you rhyme this result of online corrections with this view of planning digit placements followed by planning movements?
The idea that first we select the grasping points and then we plan the movement path towards them. It's mainly based on the results of the experiment of chapter number 2, where we provide some evidence that people first select the grasping locations, at least before planning the movement towards them. Of course, if a situation becomes different during the execution of such a movement, like in chapter 6, then people may be happy to change the grasping locations because they consider the new situation a bit different. Therefore, it's logical to change also their planning of the trajectory so that vendors will reach these new planned locations.
So does this mean that you think of the movement planning as updating an existing plan or replanning?
I believe that, especially on the basis of our findings in the last experiment, I believe that people do not add new plans to their already existing one, but they have two, let's say, patterns of responding to perturbations, one automatic, which is really fast, and one that reconsiders the new situations and leads to replanning. Because the fact that people are able to rotate their grip in the opposite direction than the rotation of the object clearly shows that this is not an automatic thing. It's not an automatic procedure, so it should be something that has been really planned to be performed.
I'm sorry to interrupt the discussion. If you like, you can extend the discussion, for instance, during the reception. But now we have to switch to the last opponent, Professor Van Dien, Professor in Biomechanics at our own faculty. Professor Van Dien.
Thank you. Dear candidate, on the authority of Director Magnificus and in my own rights, I would like to discuss your thesis with you, but first I would like to compliment you on your excellent planning abilities. When setting a date for this defense several weeks ago, you must have anticipated that record-breaking temperatures were expected for today. This would have put you at an advantage relative to us as opposition, given your Mediterranean background, of course, and given the fact that they make us wear these gowns at these occasions. Fortunately for us, the weather is slightly better than predicted. I would also like to compliment you, of course, on your thesis, and I would like to extend my compliments and congratulations to your supervisors. And your supervisors have a tradition of approaching motor control in an abstract way without much regard to how this control is anchored in the neuromusculoskeletal system. This has been a very fruitful tradition that you actually followed as well, but I think you may be taking it a bit too far. And for that I need to go to chapter 3, where you explain your findings on obstacle avoiding based on a presumed anatomical difference between the fingers and the thumb. On page 52 you state, perhaps the finger is just more flexible due to the additional joint. I was wondering what joint you were thinking of.
Learned opponent, thank you for your compliments and nice words. In page 52 we try to explain why we find the systematic effect of the obstacle, the thumb's grasping points, and not when the obstacle was at the index finger's grasping point. We try to speculate possible reasons for such a finding. Amongst others, we refer to the extra joint that
But again, can you tell me what joint that would be?
Well, there is already an extra joint on the
Well, anatomy textbooks will tell you that the thumb has the same number of joints as all the other fingers. And moreover, it has an extra degree of freedom with respect to the palm of the hand, which is actually considered a milestone in human evolution. And I don't think you would be studying grasping if we didn't have an opposable thumb. But let's move on to more important issues. Based on your results in chapter 2 and very explicitly in your epilogue, you dismiss the equilibrium point hypothesis as an explanation of, let's say, the trajectory towards the grasping points. And I'm wondering whether that's correct. If I follow the interpretation of grasping as basically moving the two fingers independently or more or less independently towards two pre-selected points. What is the object that is being lifted then, more than maybe something considered in planning, but during execution of the movement, nothing else than an obstacle? And if we consider the object as an obstacle, wouldn't the equilibrium point hypothesis be perfectly able then to predict these changes in trajectories?
Well, I think the equilibrium point control hypothesis states that a movement is generated towards a specific position, and if this were the case, then I would expect that the movements towards different objects in chapter 2 would be the same. So the fact that people change, they select different hand paths towards the endpoints, means that although equilibrium point hypothesis may partly explain the findings, people also consider other aspects of the environment and plan their movement in a different way.
But I do think that the proponents of the equilibrium point control hypothesis have already sort of solved the problems of dealing with obstacles by including a via point in the planning of the trajectory.
This is true, and this has been implemented in other models as well, that via points have an important role on the way movements are planned, and this could perhaps be an additional explanation of the different trajectories that we find in chapter 2 for the different objects.
Hora est!
Now that my defense has ended, I sincerely thank the opponents for the attention that they have devoted to my thesis. I now look forward to the decision of the Doctoral Examination Committee in the Faculty of Human Influence Sciences, which will decide whether the degree of doctor will be granted to me.
I hereby adjourn this public meeting of the PhD Committee of the Faculty of Human Movement Sciences for further deliberations. Please be seated. I hereby reopen this public meeting. By the virtue of the power vested in it, the PhD Committee of the Faculty of Human Movement Sciences has decided to grant the title of doctor to you, Dimitris Voudouris. Professor Smeets, who has been appointed as the promoter by the College of Deans, will perform the investiture ceremony. I invite the promoter and the co-promoter to sign the degree certificate. May I now request our colleague Smeets to perform the ceremony of investiture. And during the pronouncement of the investiture formula, only the members of the PhD committee stand.
By virtue of the authority vested in me by the statute of the Vrije Universiteit and as supervisor appointed thereto by the College of Deans, I hereby confer on you, Dimitris Voudouris, the degree of doctor, together with all rights, privileges and responsibilities thereto appertaining. In witness thereof, the seal of the university and signatures of the rector and the supervisors have been affixed to the diploma you are about to receive.
Dr. Voudouris, congratulations. Dear Dimitris, you can now start to relax. So it's time to talk about your favorite pastime, which is having beer with your friends. Don't worry, I won't keep you away from that too long, but I can't help talking about it a bit. I think your years here have probably ruined the experience for you forever, and I hope you'll forgive us. While your friends pick up their beers and enjoy the sun, thinking about old rock bands, you haven't started grasping the glass. Where should you place your fingers? Where should you look? How can you make sure not to knock over your friend's glass? What if your beer starts rotating? What if the previous beers influenced your balance? What if, and during all this, you just forget to drink your beer? Remaining at the topic of beer, you probably didn't notice it, but you're really adapting to the Dutch way of life. At least the temporal aspects. Because otherwise you would feel strange about inviting your friends and colleagues for some beers just before lunch. But that's enough about beer. When you just arrived here, you indicated 2 goals for these past years. And we've just seen that you have achieved one of them. Rumor has it that you also achieved the other one, although I haven't seen the data. But I guess the Amsterdam lampposts are now safe. The main thing, though, is that you further developed your skills in doing research, all the way from applying for grants to publishing papers. The Greek grant that you applied for is the reason that you can now stay for some more months here to work on some exciting new stuff. Hopefully by then Maria will also be ready and the 2 of you can find a good place to continue doing science, preferably within driving distance. In the beginning we had some puzzling moments. I still remember explaining something about rotations to you and seeing you look more and more bewildered. I started thinking that you hadn't learned trigonometry at school or something like that and didn't really know how to proceed when you suddenly asked me why I was talking about phi all the time but never specified phi. Of course, I was writing psi and calling it phi. They seem quite similar to me, but of course they don't to you. After that, I was careful never to go beyond delta in any explanation. Your work went very smoothly, and that wasn't because the results were always as we expected, because they never were. It's also not because your studies were all successful. The attempt at fMRI in London was successful in terms of getting it to work, but the outcome of the first measurements didn't suggest that we would be able to answer the question that we wanted to answer with that study, so you didn't pursue it any further. I think the reason your work went so smoothly is related to your calm way of working. You don't panic when things don't go as you expected, but just try to examine why and what it means. And this calm approach is that of a true scientist. And of course, it's also pleasant for your colleagues. It's been great fun working with you, and it still is, of course. I'm also very grateful for you the help you gave at various times, such as when we organized a meeting on optimizing performance in dynamic environments. Last summer, you knew exactly when and how to help, and because of that, the meeting went quite smoothly, I think. I'm counting on still having fun together for some time, measuring eye movements during grasping, and after that I hope you and Maria will both find a place to work Of course, it would be nice if it was either in Thessaloniki or here, but I'm sure you'll also do well and have fun if it's somewhere else. So I guess I should stop now, otherwise you'll be justified in criticizing me for having a too long introduction to the celebrations. Sinchate Diria.
Dr. Voudouris, it is my very pleasure to congratulate you with your degree on behalf of the Council of Deans of the Vrije University, and also on behalf of the Faculty of Human Movement Sciences. And it also implies congratulations to your family and your friends. During the preparation for a ceremony like this, I like to be informed about the content of the thesis, and normally I read, in that case, the summary. In your cases, I had 3 options: an English one, a Dutch one, and a Greek one. The choice was rather easy because the English summary was only 2 pages, the Dutch was less than 2.5 pages, but the Greek summary was 7 pages. The name of the Lord be praised now and forevermore.
Okay.